So in this video we're going to look at antimatter. So we've previously met the proton, neutron and electron, but we also met the antineutrino, and that's the antiparticle of the neutrino. So we've kind of already encountered antiparticles so far, but we didn't really know what a neutrino was, let alone what an antineutrino was, so that didn't do much good for us. Where we remember that the proton was positive, this neutron was neutral, electrons were negatively charged, and antineutrino had no charge as well. So are there more of these antiparticles like this antineutrino? And the answer is yes. Every particle has an antiparticle associated with it, the ones we've met so far, and all the particles we haven't met as well. So there's antiparticles for the proton and the neutron and the electron, but also plenty of other particles we haven't met yet, and plenty of other antiparticles for those particles. So we've got this table here for examples, and we're basically going to go through and fill this out as we go through. And we can start by just labelling in the things we know. First thing is to realise that we use basically symbols for all of these particles to make life a bit easier for us, so that we don't have to keep writing out proton or neutron, etc., or antiproton. And so what we do is we give proton the symbol P. That's very simple, just P. The neutron has the symbol just N. The electron, well, we've seen a few varying, we've seen basically we can give electrons the beta minus, and that's the one we're going to use here, but also we will see that we can just call them E as well, but we'll use beta minus here for now, and we'll stick with that until it's appropriate to change. And then finally the antineutrino, remember, was this nu, but then with a bar over the top, like so. And those are the particles we come across so far. So the thing we need to notice is that this bar over the top is actually how we denote antiparticles. So putting a bar over the top of the particle is a way of showing that it's the antiparticle of that particle. And that's something we'll see as we go through and fill in these other ones. But for now, let's just fill out what we know. So the proton has the symbol P. And we're just going to write down basically the rest energies for all of these particles so that we get just an idea of the kind of values we're talking about. So the rest energy of a proton, and we're just going to do them to 3 significant figures just to avoid, we don't need to be too accurate here, too specific. We'll just go to 3 significant figures. And the rest energy of a proton in mega electron volts, remembering that we saw last time that 1 mega electron volt was 1.60 times 10 to the minus 13 joules. We see that the rest energy of a proton is just 938 mega electron volts. Excuse me. So it's 938 mega electron volts, and the charge relative to a proton, well, remember the proton has a charge of 1.60 times 10 to the minus 13 joules, and its charge relative to itself is clearly just +1.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.